So sometimes your vectors are not parallel, and when they are not parallel, you cannot just add and subtract their magnitudes. For example, you can look at this drawing here. You have two vectors, they are not parallel. So what to do? Okay, so there are a few methods to solve this problem. I'm going to start with the first one, which is scaled drawing. In this video, we are going to look at a past year paper from May, June 18, paper 2-1, question 1C. You can look for it in your handout or where you normally get your past year questions. We're going to study how to find the resultant velocity of an aircraft. So let's read the question using the scale drawing method. Okay, so we have an aircraft traveling in wind, flying, okay, and figure 1.2, which is this drawing, shows the velocities of the aircraft in still air and for the wind. Okay, so right now, this aircraft is just flying. This one is in still air. So if you read the question, right, it says here that the velocity of the aircraft in still air is 95 meters per second. So this is 95, right? And you are going to look at this side. It says that it is headed to the west. So this aircraft is pointing to the west. So if you are a little bit not sure, you can always draw something like that on the side. North pole, whenever you look at the world map, is here. Okay, south is down here. East is where Malaysia is, Southeast Asia. Our country is somewhere here on the map, represent. Okay, and west is here. So when you look at this is pointing to the west. Okay, and you see the second vector, which is this wind velocity is 28. This is 28 meters per second, 65 degrees south of east. So this question is very nice. They draw for you already where the resultant, where is the 65 degrees south of east is. But in case they don't draw, here's how you can see where 65 south of east look like. Okay, so number one, you can draw the crosshair here. Okay, and when they say 65 south of east, it's pointing towards. So here is pointing towards. So you always draw at the end. Just like, for example, for this aircraft velocity, you will draw here. And the aircraft velocity is pointing in this direction. Okay, so it's pointing to the west. So right now, what we'll do, you can see this is south, this is east. So it's 65 degrees from east or south to rotate to the south. So 65 degrees south of east. So you start at east, start here, and then you rotate 65 degrees towards the south direction. Okay, but most of the time, good news is we will draw for you. Okay, so once we get that out of the way, we now want to find the resultant velocity here. Part 1. On figure 1.2, draw an arrow, label R, in the direction of the resultant velocity of the aircraft. And part 2, determine the magnitude of this resultant velocity. Okay, so we are going to stare at the vector diagram a bit. And a common mistake is you see a triangle, then you feel like, oh, I should draw like that. Nope, move. This one is nope, move. Because if you look at the arrow, I follow the direction of wind velocity. So let me change color a bit. Let's say I follow the direction of wind velocity. Okay. And let's say this wind velocity is going in this direction. Okay, roughly lah. And then it goes in this direction too. But how does it fit in the blue arrow? So obviously not like that lor. Okay. So you cannot draw this because this doesn't make sense. Your arrows must follow one after the other. So in this case, I will just silently rub this off. Okay. And what I'll do during the exam, okay, because this is paper 2, so this one is printed out for you, is I'll take my ruler, okay, and I will measure the length of this wind velocity. Okay, so I don't have a ruler, but I'll measure the length. So whatever this length is, I'm going to copy and paste here as parallel as possible. But if you just want to be extra careful, then bring with you a protractor into the exam hall. Have a protractor with you. Okay, so let me highlight this one. Change the color a bit. So this is your wind velocity and also your 28 meter per second. All right. So you measure the length, must be the same length. Okay. And then now you look at this, you can see, oh, well, first I move to the west like this. And then I move up like this. Isn't it the same as us moving directly in this way? Yes. Okay. So just imagine yourself walking the path, which is the easiest way to do that visualizing. Okay, so I'm going to draw that resultant vector now. I'm just going to use blue color and I'll try to draw a best arrow now. Okay, so it's going to look something like this. So you should be able to draw an R that is roughly pointing in this direction. Okay, and please label this arrow lah. They ask you to label R, you also label law. So this one is R. Okay, so you draw this, you get 1 mark already. Teacher, if not very accurate, can because this is just drawing. So if you draw in that direction, you will get the first mark. But when it comes to magnitude, right now, if you actually measure using your ruler, then you can look for the magnitude. So if you print out the notes that I've given you, because, you know, I wanted to save you some printing costs, I shrink the page, okay? So when I shrink the page, I would shrink the scale as well. So to make you understand what is going on, I am going to copy the diagram into a piece of paper and show you how it looks like when you draw this on your own. Okay, so I'm back. All right, so this little baby here is recording my hands. All right, and I'm going to try to draw this out on a piece of A4 paper. Okay, so normally during the exam, not in COVID-19 time, they will print out a paper for you. You can print this out in the full size if you go and find the actual May, June 18 paper. Okay, and then you can actually measure the lengths to find out what scales they're using. But right now, let's say I don't have that. So I'm just going to use the good old 1 cm, because you can see the biggest number here is 95. This one here, 95. Okay. So I'm going to use the scale, and I will denote the scale large here. The scale here that I will use is 1 cm is equivalent to, so scale equal, 1 cm is equivalent to 10 meter per second. Okay. So in this case, right, it really is up to the drawing that you are given, and then you measure. So you will take your ruler and try to measure. Oh, you see here? This one is 9.5. So if 9.5, and then I'll draw an arrow here to represent, this is 95 meter per second. Okay, so 9.5 cm is equivalent to 95 meter per second. So then I divide by 10, 9.5 cm, 95. Yeah. So now I'm going to draw my wind velocity. Wind velocity is at some angle like this. Measured from this line is 65. Okay, this angle here, measured from the line is 65. So to be able to measure out that angle, I have with me my trusty protractor. And when you measure, right, you should always try to understand that the angle, the center of the angle is here. This part, this 65 here. Okay, let me show you. The center of the angle is here. Meaning to say, the center of my compass should also be there. Because now I want to measure 65. Okay, so of course, if let's say you want to measure 65 down here, then I will rotate this one down here like that. Can So align this blue color line, the original line, to 0. Okay, you align this one to 0. And then if you want 65, what you will do is you will add the degree. Okay, so you're going to add like 10, 20. So you can always just check 65 is here, somewhere here. So here to here is 65, kind of makes sense. All right, so always use that to double check. Oh, then how? Okay, so I'm gonna just mark out 65. 65 is here and put a dot. Okay, I don't care about the length, I just want the angle here, dot. So this means if I join any point between here, the center of the protractor, and here, I'll get 65 degrees from the line. All right, so this is for you if you don't know this. So I'm going to draw 2.8 cm. I'm just going to make sure my ruler is aligned here like that. Okay, align with the dot. So I make bigger so you can see. I align like that. Okay, so 2.8. So I'm going to draw. Okay, I've got a bit of parallax error, but I'll try my best. 2.5. 2.8 is somewhere here, and I'm drawing with pen. Danger. Okay, so I'll mark this one out for myself. This is 65 degree. And this wind speed is a wind speed 28 meter per second. So this diagram, assume this diagram is given to you in the exam. Okay. And you measure the length of this or this to get the scale. So now what do? Is you measure out this 2.8 cm and then you extrapolate and transfer him. Basically repeating what I did just now, but on the actual paper. So if you want to be extra like accurate, a compass will help. Okay, a protractor will help, or a compass. So in this case, I want 65 degree on this side, alternate angle. Okay, this side, if you look at the one note behind my head, this side will be 65. Okay, alternate angle here and here. So I'm going to mark that out. 65 would be dun, 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 dun. So we read the bottom scale, obviously, right? Okay, we're going to read the bottom scale because it doesn't make sense that here to here is 125. Let me move a bit so you can see. So it doesn't make sense that here to here is 125. So it should be 65. Read the bottom scale. Okay, so if you put it properly, they should all align on somewhat of a straight line now. But of course, again, all of this is parallax error because I can't put my eye here. So yeah. Okay. So again, just try my best to align the lines. And from here, what I'll get for 2.8, 2.8 is somewhere here. So I can just continue this line one, this dot. Okay, so I shall do that. Well, of course, a protractor is also okay. So this is 2.8. And I'm moving it up. This one is here. Of course, you can erase this one if you use pencil. Same vector. Vector can move around one. So if you want to find the resultant will be to join from where you started here, move to the left, okay, and then go upwards. Start here, turn up. So I will join the starting point to the end point. As accurate as possible using pencil if you follow the drawing method. And then you double-headed arrow here. Label this one as R. Now, I take the ruler and I try to measure the length. So if I check on the length, for me, it looks like, I don't know, man. Okay, I'm going to put it here so you can, maybe I should lower the camera a bit so you can see a bit clearer. Then it'll be a bit off range. Give me a sec. Dun, dun, dun. Okay. So I'll try my best to align here. Notice the uncertainty. You take one reading here, half a scale uncertainty, where the 0 is. Go here, another uncertainty, half a scale. So I'm thinking this is around 11. I don't know. Maybe yours would be more accurate. You draw yours, okay? Without the limitations of camera blocking your parallax error. So half a small scale, there are two uncertainties when you start measuring, when you end measuring. Because of the two reading, the uncertainty is actually plus minus 1 mm. So I think it's around 1 mm-ish. Okay, so I'm going to write it down. Okay, so just make a note here that the resultant velocity, come over here so you can see, resultant velocity will be equal to 11.0 cm. If you want to write it with the uncertainty, then you will say 11.0 plus minus 0.1 cm. Okay, but this is theory paper, so we can stick to 11.0 cm. Okay, but you're going to have to multiply this by the scale. So the scale is 10 meter per second for every cm. So the cm and cm will cancel. And when they cancel, what you will get is 110 meter per second, which is the speed of the aircraft. Okay, so if you want to include the uncertainty, then you're going to have to times 10. The uncertainty also have to times 10, right? So then let's say this is V. Oh no, wait, this is R. Sorry, this is R. Okay, so if you want to find the uncertainty in R, I'll just continue here. Okay, uncertainty in R will be equal to plus minus 0.1 cm multiplied by the scale. I'm just teaching this extra. It's not needed in the question. I repeat, not needed in the question. I'm just doing this extra. Okay, in case they ask lah, how you know they don't ask? Okay, so anyway, you can cancel these two, and your absolute uncertainty with plus minus 1 meter per second. So if you want to write your final answer, you can say R plus minus uncertainty in R, being the resultant velocity, will be 110 plus minus 1, okay, meter per second. This is how you can write your final form. Of course, if yours is not 11, then you do something else lah. But your absolute uncertainty here must be correct. Okay, so just a note here, this absolute uncertainty, this 0.1 is smallest, half the smallest reading times 2. So it's the smallest reading. Because when you put the ruler here and you measure the length of the red line, here got uncertainty liao. Here another uncertainty. Half a scale, 1 smallest reading. Okay, not the same as chemistry, for those of you who do chemistry. Okay, so done already. So this means, right, during the exam, if you actually, because this blue thing is drawn for you, down here draw for you already. What you need to do is to copy paste the arrow and put here, and then join, and then take your ruler to measure the length and to find the scale of this black line first, and then to measure this length to find R. I think it's okay lah. I think you already started, you have to draw R to get 1 mark. So if you draw R, you get 1 mark. Okay. If your scale drawing is labeled correctly and then you measure this, you get 1 mark. Okay, final answer is 1 mark. So that means you are already halfway there. Scale drawing is workable. But as you can see, it is full of uncertainty, right? And the mark scheme allowed answer is actually quite generous. They will allow 108 to 112 meter per second. Okay, so it's a quite a large range, if I do say so myself. Okay, so first method done. You draw the triangle correctly, please label everything. You draw the R correctly, you get 1 mark. The rest of the triangle properly built should be there. If not, 1 mark can be deducted. Okay, so the triangle drawing is 1 mark. Then you show all these calculations is actually the same mark. My bad. This one is the same mark. Okay, I will scan this and put in the notes for you. But yeah, that's the whole idea. So scale drawing, when you draw this, because you already did this, so it's just a little bit of step to add on. But some of you who are like, teacher, this range very big leh. I like accurate answer. I want to be more precise. Okay, I hear you. You want to decrease your percentage uncertainty. You don't like this large range. I get it. So another method is to use solution of triangles. Okay, so some of you who do add maths, you're like itching, like, teacher, I know the length of this blue line. I can calculate using equation. Okay, so the second part of the video, I will show you how to use solution of triangles. Okay, but if you're happy with this method, that's all. Okay, if you want to know solution of triangle, keep watching. If you're here, you are interested in the solutions of triangle method. So how does that look like? Let me story you the equation. If you have a triangle like this, I'm going to talk about the cosine rule. Okay, and this line is A, this line is B, this line is C. Okay, let's say this angle is capital B lah. Okay, so cosine rule states that B square is equal to A square plus C square minus 2AC. Okay, so basically we're doing hopscotch or jumping across the triangle. I want to find this length B. So this length square is these two sides, A square plus C square minus 2 times A times C cos B. Move it here, leave it space. It's cos B. I'm going to apply it there, okay? So I will say using, because I already draw the diagram. Don't waste my solution of triangles or the cosine rule, okay? R square is equal to 28 square plus 95 square minus 2 times 28 times 95, whatever you write here, no? The other two sides, cos, what's the angle? This is the angle opposite to the side that you are looking for. So this is 125. Is it 125? Is it 115? 115, my bad. Okay, because it's 180 minus 65. So 115. So this is cos 115. Okay, so you can press Casio the calculator. Okay, and if you press it properly, can press it with you lah. Nah, my slightly not so true calculator. Hang on, let me move this a bit. Okay, so cos 115. Okay now, so if I press my calculator, minus 2 times 2, 8 times 9, 5. Please make sure your calculator here is in degree, not radian. The rest you just let calculator do the job. Look. Square root answer. Ta-da! 109.8. About 11. 110. Okay. So I'm going to write this to 2SF or 3SF. 110 meter per second. So my drawing pretty good. Quite accurate. I'm happy. Okay. So you can always also use this to double check if you're strong in maths. If you're not good in maths, it's okay, guys. It's fine. Drawing the diagram is perfectly legit. Just park your arrow there and measure. Bring your arrow. Bring your ruler. Put your ruler there and measure. I'm not going to edit that part out. And then bring your protractor. All right. So scale drawing method. Use solutions of triangle to double check your answer. I will see you in the next video for the second method if you really don't like to draw. Bye-bye.